chapter 2 for physics called electricity. Well, in this chapter, by looking at this, the word electricity, what does it mean by that? First thing come first, that would be electricity. City means movement. Electric means electron. So, put in a simpler form, this chapter is all about the movement of an electron. Okay, this chapter we're going to study how an electron moves. You may regard electron as a ball or a particle. Okay, where the electron, it has charge, and the charge is negative 1.6 is a constant number. You don't actually need to memorize it, because as time goes by, you go through all the exercise question, you kind of like you can just mention it out of nothing. It's negative 1.6 times 10 power negative 19 coulomb unit for the charge. I think it is still a bit early to throw you at this term, but since we talk about electron, I might as well let you know about the charge value, coulomb, capital C. Okay, if it were to be positive charge, then it's a positive. If it's negative charge, then it's negative 1.6 times 10 negative 19 coulomb. Okay, so let's come back to the chapter 2, which we call electricity, movement, electron. Now, how do you see the movement? Okay, one way, because what happens is it's so small until you can't really see it. You may, if you regard electron as a particle, you can't see it. So one way is to probe it, or you test it. How to do that? First of all, you have Van de Graaff. I'm not sure you have this at school, but you may Google for this device, Van de Graaff. Okay, it's actually a dome, a metallic hollow dome. Okay, I mean a cross-sectional view. It's a dome, a hollow. What happened? It has a rubber belting system. It's a belt system run in the middle, and then touches at one side of the dome, and then when you switch it on for maybe 10 to 15 minutes, then this belt will, what happen? This belt would discharge the electron. Okay, will bring away the electron from the metallic dome. And what happens if you bring away the electron? Because the electron is at the outside-most of an atom. So what happens? You bring away the electron, so this surface will become positively charged. Okay, it become positively charged. You can't see those charges, just that you have electric field. Okay, you bring away the electron, then it will be positively charged. Then what happens? You stop this motor, and then you bring near a galvanometer. Okay, a galvanometer. In this chapter, you get to use quite a lot of devices, because it helps you to probe what is moving from which side to which side. Okay, whether it's left to right, right to left, and then one side of this you connect to the earth, and also you are supposed to know how to draw earth, meaning it's to the earth, and then another side of the wire you have a copper or metallic sheets. When you bring near it, what happens? Before you bring near it, you are supposed to stop it. Okay, So the Van de Graaff is in positively charged. So when you bring near it, the moment you bring near it, what happens is electron from the Earth will start to flow, and then neutralize the dome, the surface of the dome. So there are few observations. First would be when the moment you bring near it, the galvanometer deflect, meaning there's a show of sign where electron is flowing, or you call it current is flowing, because the movement of electron means current is flowing. Where does it come from? It comes from the Earth, travel through the metallic piece of probe, and then bring near it, it neutralize the Van de Graaff surface. So this is what happened. So this experiment actually tells how electron is transferred or moved from one side to another. Then another better example that you will normally deal with, because Van de Graaff, I think not every school will equip with Van de Graaff for SPM lab. So another way to look at the flow of an electron and how they are related to current is a dry cell or the battery, right? So for a battery, come enlarge it. It's actually a chemical reaction where the chemical energy, electrochemical reaction produces electron, and then the flow, it will get electricity. So what happened is inside this chemical you have a dry cell, and then what happened, this is a positive side, this is a negative side. Where you want to draw in, you put in a circuit, what happened, this one is like a battery, positive, negative, positive, negative, positive battery. But what happened is this chemical reaction, the electron flow, you will have some kind of resistance, we call internal resistance. So I'm going to put a resistance inside before you go out, okay? Then you may connect it over a load, maybe a load. You have a light bulb, okay? So what happened, this is a positive terminal, this is negative terminal. Now when this is a closed circuit, what happened is the electron flow from the negative side. Electron flow from the negative to positive. This is where you have lots of electron will flow out from the negative terminal. Whereas for current always move from positive to negative through the external circuit. This is the current unit I. So current flow from positive to negative, electron flow from negative to positive. Okay? Why it will flow? Electron will flow from negative to positive. Why is it so? Because they are potential difference. I will talk about it later in next page perhaps. But another way to talk about it is why the negative go to positive is because of Coulomb's law. Is a similar charge similar charge, repel. Okay. Opposite charge, attract. Just like boy attracted to girls, boy and boys, they will fight. Okay, similar charge, repel, opposite charge, attract. CT. Okay, so this is called the Coulomb's law. And normally comes out in the objective question. Alright, then it's quite theoretical. I'm sure you can get those theory. I mean, you will help you out with your reading later. Then we talk about current. What is current? Okay, current. Now, this is a major part of for this chapter because you will find quite a few calculation, and the calculation is very much based on current. Okay, current by definition, current I is actually called the rate change of charge. That's all. Meaning current is defined as how many electron flow per unit time. Okay, electric current is the rate change rate of electric charge. Okay, rate of electric charge, meaning where Q is actually number of electron, or another way of doing it is actually Q is number of electron, n times E, I mean electron charge, where E is the constant. Okay, number is number. Maybe let's say 1 second there are 20,000 electrons, so 20,000 times this constant number. Okay, you may find this constant number in your calculator, depending on which model you are using. So look for the E and look for this number. You may want to press shift 32, I think. It depends on your model. I don't know which model calculator you're using. It's a constant. You doesn't really need to memorize it. You just need to recognize it. Okay, just to be sure you press on the right constant. It's negative 1.6 times 10 negative 19. So you substitute into here, and E, then over time, how many seconds, then current, where current, unit for current, is actually called ampere. Special unit, ampere, A. Okay. Alright, so this is about current, number of electron per unit time. This is time. Okay, where T is time in second. Alright, so in some exercise in your reference or text, you may pause the video. So another way of doing Q, so what is actually Q? Q would therefore be equals to I times T. Unit for Q, come back to Coulomb. Coulomb, capital C. So 1 Coulomb would therefore be equals to 1 ampere second. Maybe this is something new in objective. It is nothing for you to memorize. It is from the equation. You derive from the equation. Where you get Q from Q, you times it up, then IT, right? I is current, ampere, time is second, ampere, second. Pretty straightforward. I hope you are following. Right, the calculation, you may pause this video and then go through the reference or exercise. Go to, about 5 to 8 questions on this current, charge, and time, and how electrons flow. Yeah, also the concept of similar charge repel, opposite charge attract. Because coming up next, we'll talk about electric field, where you are supposed to recognize the field line, because in some structure question, or maybe even some objective question, you are asked to identify which one is the right drawing. Okay, so to start out with, that will be on electric field. Now, what is electric field? Electric field is a region where you have electric force. You will get to know more about this in electromagnetic field. So, say for example, if you were to have a positive charge, how the field should look like. If it were to be circular or sphere, the field line, suppose it's symmetrical, then it will be line going out. Okay, originated from the circle, and then the arrow outwards. When it's outwards, means it's positive. When it's inward, outward, okay, it's positive. And when it's negative, if a negative charge, the field line would be going into it. Okay, alright, just like the circuit, the current is going into the negative field. Like in the terminal, current is flowing outwards. I think one way to help you out with it, I hope it helps you out. So it's actually a vector quantity, it's a vector. I hope you know what's active by now, because in Form 4 we have gone through it, where they will have force and also direction. Okay, so the amount of line coming out from the positive meaning is very intense, very strong. Okay, and this pattern is not always the same, because it's very much depends on the shape. And also the number of charge object. What does it mean? How many of them come near together in the following example? If I place a positive charge close to a positive charge, this is one good example. When two boys come together, they would fight, right? So what happened? The pattern now changes, because so close. What happened? It will be wow, wow, wow. Okay, and then it won't go be straight. It will be like very much, but then this one will be straight. Okay, going outwards. Okay, all right. happen to the center here, this is called the neutral point. This one here is actually called the neutral point. Neutral point. This neutral point has got no electric field at all. Neutral point. And then another example, depending on the shape, yeah, this is here come together. Another one is a parallel plate. One plate, copper plate maybe. They are close together. And then one connected to the positive terminal, another connected to the negative terminal. Then the magnetic field, okay? The one, the center, they are going to be parallel. Always from positive to negative. I'll talk about current. But one at the side, you're going to have fringes. 1, 2, okay? Just to draw a few. The one at the side are called fringes. Okay? But normally in study, we study only the parallel line. The one fringes we normally omit. We don't study them. Okay? Then, what is so great about these two? Let's say come back to here. Okay, they are so far apart, what can you do about it? Okay, you can't do much about it. So, what I'm going to show you next would be the term called potential difference, because positive have more potential to push an electron from negative to positive, right? I mean the movement of electron. This is current movement, right? So, what I'm going to show you is called potential difference. Potential difference, capital V, volt, like we mentioned volt. What is volt? Okay, volt is actually called the work done for what? In moving an electron, or you don't move an electron. Maybe you in moving. A more general way of saying, in moving a charge. Move a charge in an electric field. Right? So it's actually here is work done, a charge, electric field. Put into equation, V, what is actually work done. Work done per unit charge. Okay? Work done per unit charge. You can have 6 electrons, so 6 times E. E is a constant. Okay? This is something that you should know because you're going to use it quite extensively. It's not just V equals to work done per unit charge. It won't be so easy because it will ask you for charge, find for volt, and things like that. You need to move around this equation. Okay, so what does it mean by that? Another way of looking at it is, say you have 2 charge. This positive and negative, let's say it's stationary. You can't move it. You fix it at a point here, left and right, and then what happens? You inject an electron. Okay, let's say you inject a positive charge. Okay, so obviously this positive charge will be moved from here to here. I mean, to the negative side. Right now, from this point left to right. So therefore, the voltage would be work done per unit charge. How many joule per coulomb? So the unit for watt is, work done is joule per unit coulomb, or special unit called watt. Okay, I think there are quite a lot of questions on objective on this issue. because sometimes they will ask you for W. What's W? W is actually voltage times charge, or Q is work over, work done over voltage. Okay, so it doesn't need to memorize the derivation. You just know that voltage potential difference is work done per unit charge, and the rest you just play around with this electron. But of course you need to really have quite a lot of work on it. Yeah, you need to I think this one I would recommend about 10 to 15 objective question on this issue, because or otherwise you really have some problem later on. Okay, after that I would stop now, because I want you to really make do with those exercise, the one with voltage, work and charge, potential difference, then current, and you really have the sense of electron movement, how to calculate charge is IT, and then relate this equation to here, where this one here is actually equals to IT, and then in some question you might need to find out what's the current, or what's the work done, etc. Okay, so it is a matter of how well you make do with these two equations. So I hope you really stop this video before you proceed to the next one. Try at least 10 or maximum 15 in 1 week time. It's not a day or two, but in a week time you try about 15 questions to fit in your time, and try to make do with electric field, how the line go out, positive out, negative in, and then this is neutral point. Okay, once I come back, I'm going to show you a very nice image of how you can make do with the charge, or the effect of the charge caused by high potential difference. With that, I hope you like those thumbs up button. Kindly press the thumbs up button. I like those, and it costs you nothing. And if it's first time watching this video, kindly subscribe to my YouTube channel for more upcoming video. Thank you.